Well, hello. It's the 7th of November. You're working on the cladogram worksheet. Yesterday, you filled in that table of characteristics so you know who's got what. And you know how many of those characteristics each species has. And I suppose we should go ahead and take a look at that top row. Do your numbers agree with the numbers up here that, what's the first category? Kangaroos have 5 of those characteristics. Lampreys have 1. What's the next one? Rhesus monkeys have 6. Bullfrogs have 3. Humans have all 7. Snapping turtles have 4, and tuna have 2. You would agree with those? Yeah. Okay, good. Well, now here's a funny thing. If we look at how many circles each of these things is inside, let's see, humans are in 1, 2, 3, 4, 5, 6. Okay, well, I see how this works. Humans should be inside 7 circles. 1 characteristic, 2 characteristics, 3 characteristics, 4 characteristics, 5 characteristics, 6 characteristics, 7 characteristics. Somehow our math is a little funky, but that's okay. I think we just had a misalignment.
I missed the circle for tuna. I think drew an extra line on accident.
Oh, okay, I see. So you should erase that line.
Yeah,
that's important.
Here, no.
That's important. Okay, so 1, 2, 3, 4, 5, 6, 7. Huh, that's odd. Humans have 7 of these derived characteristics and they're inside 7 circles. Do you think there's any connection? No, it's probably just random. Lampreys have only 1 of these characteristics and they're inside or on only 1 circle. Huh. What do you know? What we're looking at is who shares all of these characteristics. So at this point, I'm going to pause this for a second. Okay, Mr. Maple is going to take over.
All right, so we've drawn in our 7 sets, right, on the start of our cladogram. Now how this is going to work is we have our dorsal nerve cord in set 1, right? What organism has that? Well, all of them, right? But the only organism that has only that thing is your lamprey. Right. So that's going to go in between your first and your second set, because it has the first set of characteristics, but not the second one. We're going to have another branch in between each set. Kind of getting where this is heading? Yeah. All right. So I want you guys to work on that one and see what we can come up with for the rest of them, okay?
So I went ahead and added the actual characteristics on that table. When you're putting an organism there, you're saying that this organism has all the characteristics that are listed below it, yes, and none of the characteristics that are listed above it. Okay? So the next organism that you're looking to place is going to have paired appendages and a dorsal nerve cord, but not have paired legs, an amniotic sac, mammary glands, a placenta, or shortened canines. Okay? So it will have everything below it. It will have nothing that is above it. What do you think comes in that next slot? So you would say tuna have paired appendages and a dorsal nerve cord, but they do not have paired legs, an amnion, mammary glands, placenta, or shortened canines. Would everybody agree? Okay. Whatever comes here, remember, has everything below it, lacks everything above it. Okay, what is on your list that's got 3 paired legs, has paired legs, has paired appendages, and a dorsal nerve cord? What do you? Bullfrogs. I like bullfrogs. Ribbit. Actually, bullfrogs. No frog says ribbit. Do you know what bullfrogs say? No. Oh shoot, I'm recording. Okay, so bullfrogs. have all three of those characteristics. Do bullfrogs have an amnion? What's an amnion again?
Amniotic sac.
Amniotic sac. You came in one. You came wrapped up and delivered in an amniotic sac. Who here has peeled a hard-boiled egg?
Me.
Okay, have you ever found a little membrane kind of thingy between the egg part that you're going to eat and the shell? Guess what that is? The amnion. I know. Has anybody here, and I will not judge you, has anybody here ever handled turtle eggs? You should not handle turtle eggs unless you have a pet turtle. Like, don't go dig up wild turtle eggs because they're having a hard enough time. But if you were to tear open a turtle egg, they have a soft leathery shell. It's not brittle like a chicken egg. And inside that soft leathery shell, guess what there is? Amniotic sac. Yeah. So what is the purpose of this amniotic sac? Well, it's not even a fetus at that point. It's just a fertilized, the zygote, then an embryo. Where do chickens lay their eggs? In their nest, in the wild, under a tree, under a bush, under a table, in a nest box, wherever they feel like it. Where do turtles lay their eggs? Under sand, under dirt, somewhere on the side of the road, whatever. Where do humans lay their eggs?
We don't.
Well, yeah, actually we kind of do. Females lay their eggs into the uterus from the ovary. It doesn't actually leave the body because we give live birth. But there is still an egg. There is still an egg, and then that fertilized egg develops inside an amnion, inside a sac. Where do frogs lay their eggs? In water. Important here. In water. So how come chickens can lay their eggs on land and turtles can lay their eggs on land and frogs can't? Because they don't have an amnion. The amnion protects the egg against desiccating. So if you got an amnion, you have got way more flexibility in terms of where you go laying your eggs. No amnion, you better keep your eggs in water. Salamanders, where do they lay their eggs? Water. Frogs, toads, all lay their eggs in water. They don't have an amnion. Huh? Pardon? Dragonflies? Dragonflies do not have an amnion, but they have some other protective mechanisms. Insects do not have amnions. So cool. Ask Mrs. Haylett about dragonfly penises. Okay. So, what on your... She wrote a paper about it. They're fantastic. What on your list has got... Oh, I'm sorry. So what on your list has got an amnion, paired legs, paired appendages which happen to be legs, and a dorsal nerve cord? Snapping turtles. Okay. So we're saying then that snapping turtles have everything down here and nothing. They don't have a placenta and they don't have shortened canines, correct? Okay, good. Yes, we like it. What on your list has got mammary glands, an amnion, paired legs, paired appendages, and a dorsal nerve cord?
The kangaroo.
The kangaroo. Where are the kangaroo's mammary glands located?
Ouch.
In the pouch. That baby doesn't have a what? You might get a clue from the cladogram.
Amnion.
Doesn't have a placenta. There's no placenta that gives nourishment to the fetus throughout the pregnancy. So they're born about half developed. They crawl into that pouch and they grab onto a nipple and they nurse for quite some time. They finish their development because there is no placenta. They're a marsupial mammal. Different track in evolution. No, that's where they finish gestating. So how many of you have known, seen, or been near a pregnant woman? Ever? Anybody had a pregnant relative or remember your mom being pregnant with other kids? Okay, so pregnant women go 40 weeks. If humans were on the same track as marsupial mammals, they'd get to about 20 weeks. That's halfway pregnant. then they would have the baby and stick it in a pocket. Not a real pocket. But, you know, at that point, the human infant is like this big. They're not fully developed. I mean, human fetuses cannot survive outside the uterus at 20 weeks. But in a marsupial mammal, that's exactly what happens. They go into that pouch, and then they just hang out there and nurse for the remainder of what would be a normal pregnancy. Yeah, they climb in and out for protection when they're a lot older. That would be the equivalent of, you know, your 12-month, 13-month-old kid crawling back into your uterus just to hang out. No! But yeah, that's the difference. Kangaroos don't have a placenta. Humans do. What other mammals have placentas? Rhesus monkeys! Why, I think I've heard that somewhere before. I'm going to shrink this whole thing down. Rhesus monkey. Who looked up a picture of a rhesus monkey? Somebody look up a picture of a rhesus monkey. Canines. You know any people who look like that? I'm hoping not. I'm hoping not. Okay, you know what? Do you know any human who's got canines that are 3 times the length of their other teeth? Okay, there we go. Huh? Well, humans and vampires, you know, if we go with the mythology, by definition, are no longer human. So we'll leave them out of the equation. Formerly human and now undead. Okay, these things right here. Those are some really terrifying canines. What species on this list does not have? Humans. So, if we told you that another species, let's say species, oops, let me shrink this. If I told you that a new species had been discovered, and that new species had mammary glands and amnion, paired legs, paired appendages, and a dorsal nerve cord, but it lacked a placenta and shortened canines, where would you put this mystery species?
Next to the kangaroo.
Yep. If it has all those characteristics, but it lacks the placenta, the mystery species would go right in with the kangaroo. Okay. You have just constructed a cladogram based on physical characteristics, based on structures that are present or absent. What's the other kind of chart that we can build? Phylogenetic tree. And, you know, I used to think that one was more based on structures, one was more based on DNA. No, people just use the terms interchangeably and not very well. On your packet, there are some questions. Can you flip to those? So what I want you to do is answer those questions on your own. Answer the questions on your own. Then discuss your answers with the people sitting at your table. See if you are in agreement.
We got our first one. What types of information can be obtained from a cladogram? So what type of information are you gaining from it, right?
All of it.
Probable relationships. You can kind of look at a cladogram and see how these organisms could be related, right? So let's check that one off. It's good to go. Probable sequence of origins. Let's look at this thing. Do you think this heading in this direction could give you a hint onto how these things have come about? Right. So I could check that one off too. Shared derived characteristics. Yeah, that's what a cladogram represents, right? What about D?
No.
No. Why? Did it say anywhere on that cladogram where these traits came about? Just kind of somewhere in those given sets, right? Okay. So the answer for this one would be what? F, all but D. Got that one? Good, good. Okay. So, if the cladogram just constructed is correct, the fossil record should show that different groups of vertebrate animals, what do we got here? First appeared at different times, each with new traits added to earlier existing traits. Possibly, right? That one. First appeared at different times, each with totally new combinations trait. All right, if you look at that thing, we got shared characteristics, right? So that one, no good. C, appeared at different times with no pattern of trait. No. What about D? What do we think? Nope. All appeared at about the same time, each with, nope. All shared. Right? So we got A. Now remember looking at the fossil record, your older stuff's towards the bottom of that rock layer, right? It just builds up to the newer stuff. So do you think that if we put all these organisms into extinction 100,000 years from now, we could see kind of a cladogram in our fossil record? I think we could.
Possibly.
Possibly. All right. So one thing you can determine from a cladogram is relatedness, right? You can look at it based on those shared characteristics. So the most closely related organism to humans in this cladogram is what? Monkey. The angry monkey, right? All right, so looking at this cladogram we created, what is the least? Lamprey, wait. Here's our humans up here. Our lampreys are way down here, right?
Yes.
Okay, so we got our lamprey. Okay, so we got our dog. Where do we put our pup?
Next to Reese's monkey.
Why?
Because it's got a placenta. Yeah, it's got a placenta, but it don't got short canines.
Doesn't have short canines?
No, they got long.
You've seen a dog, right? You've got these. It does not have shortened canines. I'm sorry. I can't spell sometimes. What's that? All right, so we put our dog right in here, right? Okay, so we got those answered. You guys were having a little bit of struggles with this one, right? So which of the following is true of these statements? Now remember looking at these cladograms. It's running in this direction, right? See these distances? This organism right here and this one are closely related, right? What about this one? Yeah, let's do a different color. This one and this one. When we look at these first two. Not as close, right? So looking at these ones. A horse is more closely related to a seal than a giraffe. Horse, seal, giraffe. They're equal distance, right? So we're not going to go with that one, right? That one's not true. What about B? A giraffe and a hippopotamus are more closely related than a giraffe and a whale. Giraffe, hippopotamus, giraffe, whale. What do you think of that one? Correct? Right, because this one has a little farther distance to go, right? Giraffe or whale? Hippopotamus and a whale are more closely related than a hippopotamus and a giraffe. No. What about D?
Yeah.
Yes, no?
Yeah.
Yes. D. Yes.
Okay, a seal is more closely related. Let me get all these out of here.
To a horse.
Seal is more closely related to a horse than a giraffe is related to a seal. So you got seal, horse, seal, giraffe. I'd agree with that one too. So we got D, and we got B is true. All right. Gonna have them turn it in this one. Are you guys gonna turn those into the box?
Of you have your Lizard Lab Module 1s returned. If you got less than a 17, you should be redoing it to make sure that you've got all the images. If you didn't graph. If you need help navigating back through, you can navigate back and forth through the lab. Because if you go ahead and log in, it's going to show it as
How do you tell?
it's going to show.
Show return, right?
It'll show return. And it should show your score. Oh, but if you go in and you hit resume, it should pop you right back in. You can go back into module 1 and complete anything you missed.
She said under 17.
Yeah, 17 and down. So if you got an 18, you don't have to redo.
Is that under 18?
Yes.
Thank you.
I just did my graph.
Okay. And if you just, you were missing a screenshot of one thing, go ahead and attach it and submit it.
It won't let me go back.
Go up to, bring it over here.
I'm just literally erasing everything.
Go to here. Generation tab. Seriously? Seriously? Generation tab? Born digital?
What?
Look at, and just to note, it said take a picture of each question. That's 7 images right there. 7 images just for your pictures.
Those graphs are
Just one image, like one question whole point. We have to have an 18.
Huh?
We have to have an 18. 17 or 18.
If you have an 18, you don't have to redo. If you have 17 and down, you need to add what you missed. You didn't get graded on whether the questions were right or not. You just had to submit them. I mean, it gave you the right answer. You could go back and redo it until you got them all right. So we didn't grade you on that. It's on the fact that you showed the question, you showed your answer. So I want to know if you got it wrong or not.
You want to talk about extra credit?
I do, thank you. Hey, Corinne reminded me. Extra credit. Who wants to talk about extra credit?
Me.
Okay. I put up what I'm calling Moser is a lazy biology teacher. I want to know stuff about stuff, and I don't have the time to look it up for myself. Lots of things I want to know. I want to know about the evolutionary stages of snakes. I want to know when the back legs disappeared. I want to know when baleen emerged in whales. We watched that whole movie about whales. I want to know when we start to see not-toothed whales with baleen emerge. Lots of things I want to know. I put up a partial list on that assignment. And I decided, and I don't think I edited the assignment yet. Here's how I'll break down the points. The very lowest level of work that you can do is you find... No, you too. Not you, you're fine. I'm grousing at the camera mostly, and Luke. Okay, so the lowest level of work that you could possibly do is just find some articles. For one article, one web page that's going to tell me something about the thing I'm curious about, you get a point. Up to 5 points. So you find 5 articles with images or whatever about the evolutionary history of snakes, a point per item, up to 5. That's low level. It probably doesn't help you learn anything. You take a couple of those articles and you then annotate them so that you're getting some information out of it, so that you're learning something about it. Up to 5 points each, up to 10 points. So right now you're at 15. So you can put in 5 articles, then you can annotate 2 of them, you're up to 15 points. Go ahead and take it the next step, which is you have a dialogue with me where you teach me about what it is that this thing is. So that means I can ask you questions like, okay, Leanna, okay, well, so then when are they saying this happened? Oh, okay, that's cool. Well, how do they explain this? Da, 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 da. And you actually teach me, that's big points, but you gotta be good, you gotta be really good for that. That's like 10 possible points. So this is a possible 25 points, but that highest level is really hard. That's, the low level's pretty easy and the mid level's not hard. So up to 15 points are pretty easy. Up to 25 would be a struggle, but that's okay. Fight that fight. Okay, I'm gonna keep returning those. These are just going to be on your own for homework. The redos will be due on, today is Tuesday, on Thursday. Yes, sir.
I have a question on what
Okay.
I was missing because, like, I found out outside and I fell the 20.
Okay.
You say you didn't know these?
I don't want those.
Okay.
What I want, let me see if this person has it. Let me find somebody who had it.